Determine the left end and right end behavior and the horizontal asymptotes, if any, or slant asymptotes, if any, for f of x equals x cubed plus 2x squared minus 4x minus 1 divided by 3 minus x squared. If the highest power in the numerator is less than or equal to the highest power in the denominator, f of x will have a horizontal asymptote. If the highest power in the numerator is greater than the highest power in the denominator, f of x will have left end and right end behaviors of positive infinity or negative infinity. If it is exactly one higher, this will happen through a slant asymptote. F of x equals x cubed plus 2x squared minus 4x minus 1 divided by 3 minus x squared. The highest power in the numerator is x to the 3. The highest power in the denominator is x to the 2. The highest power in the numerator is greater than the highest power in the denominator, so left end and right end behaviors will be positive infinity or negative infinity. Since the highest power in the numerator is exactly 1 higher than the highest power in the denominator, 3 is 1 higher than 2, this will happen through a slant asymptote. So f of x will have a slant asymptote. The slant asymptote is determined by dividing the denominator into the numerator. I'm going to write the denominator in descending order, so the negative x squared first, then the positive 3, to make the division a little bit easier to handle. Dividing it into the entire numerator. The first thing to do is to determine what we need to multiply the first term here by to match the first term here. We need to multiply by a negative to make it positive, and we need one more x. We need to multiply by a negative x to turn negative x squared into a positive x cubed. We can put the negative x here, and now this entire thing is multiplied by a negative x. The result will be a positive x cubed, which I will write under the x cubed term, and a negative 3x, which I will write over here under the negative 4x. The entire thing is put in parentheses, and the entire thing is subtracted. X cubed minus x cubed will fully cancel. The 2x squared has nothing to subtract from it, so it will just move down. Minus 4x minus a negative 3x, which is the same thing as plus 3x, minus 4x plus 3x is negative x. And the result of negative x is put down here, and then the minus 1 can be moved down. It has nothing to subtract with. The next thing to do is to determine what we need to multiply this first term by to match this first term. It needs to become positive, so again it'll be multiplied by a negative, and it needs to become a 2x squared, so it'll need to be multiplied by a negative 2. The negative 2 is put up here. We now multiply each of these by a negative 2, which will give a positive 2x squared and a negative 6, which I will write it under the negative 1. The entire thing is put in parentheses. The entire thing is subtracted. 2x squared minus 2x squared cancel out. The negative x has nothing to subtract with, and it will just move down as negative x. Minus 1 minus a negative 6, which is the same thing as plus 6, minus 1 plus 6 is a 5. The negative x squared cannot further divide into negative x, so the negative x plus 5 is the remainder. And it will be over and being divided by negative x squared plus 3. The slant asymptote is the linear function that results ignoring the remainder. The slant asymptote will be y equals negative x minus 2. Now to show that this is the case, f of x is x cubed plus 2x squared minus 4x minus 1 divided by 3 minus x squared. After long division, this is equal to negative x minus 2 plus a negative x plus 5 divided by a negative x squared plus 3. The slant asymptote is determined by y equals the limit as x approaches positive or negative infinity of f of x, negative x minus 2, let's say negative x plus 5 divided by negative x squared plus 3. Since the power in the remainder term in the denominator is higher than the power in the remainder term in the numerator, the remainder would go to 0 as x approaches positive or negative infinity. And the result is negative x minus 2. And therefore, f of x has a slant asymptote of y equals negative x minus 2.